Okay, Assalamualaikum and good day everyone. So today we are going to proceed with the last subtopic in Laplace transform, which is initial value problem. But before that, let us recall what we have done uh, in this chapter. So the first one is I already teach you on how to find the Laplace transform from ft to get your fs by using Laplace transform. And we also cover properties of Laplace transform, which is linearity properties, first shift, and also multiplying by the n function. Next, we already covered how to find the inverse Laplace transform, which means from Fs to get your Ft by using inverse Laplace transform. And we also learned the properties of inverse Laplace transform, which include linearity properties, first shift properties, and also inverse Laplace transform of rational function or partial fraction. So now we are going to use all this knowledge to solve initial value problem, which include first order and second order linear differential equation. This is where we are going to use all we had learned before to solve first order and second order linear differential equation. So in your notes, I already provide you the steps on how to solve initial value problem. Okay, so we will follow these steps. Okay, so let's consider the first example, which is this one is for first order first. Okay, first order linear differential equation. Okay, so let's say you have this problem. Y prime plus 3y is equals to sine t, and you are given an initial condition y0 is equals to 0. Okay, so what is the difference between this one with the previous chapter is that the function on your right hand side here is in terms of t function. Okay, so that's why we need to apply Laplace transform. So why this one is called first order? Because the highest degree for dy dx is 1, which is this one, y prime or dy dx. Okay, so how to solve this first order by using Laplace transform? So the first step is you have to find the Laplace transform of each of the following term. Okay, so that is the first step. So you need to transform. So if you refer to your notes, first step is you need to transform your differential equation in terms of ys, which means you have to find the inverse of all these terms. Okay, so Laplace of y prime plus, so 3 is a constant, so you need to factorize 3. So 3 Laplace of y is equals to Laplace of sine t. Okay, so what is the Laplace of y prime and Laplace of y? So I already guide you with this one. Or if you take a look at the table of Laplace transform, you also have it. This one. Okay, so as you can see here, in your table of Laplace transform, you are given y prime and also y double prime. So this is Laplace transform of y prime t is equals to this one. Laplace transform of y double prime t is equals to this expression. Okay? And you have to know Laplace of yt is equals to ys. This one you should know because at the beginning of this chapter, I already teach you we apply Laplace transform from t domain to s domain. So if you have ft, then you will have fs. So if you have yt here, then Laplace of this one will give you ys. Okay. So therefore, you substitute Laplace of y prime, which is equals to sys minus y0. Okay, so you will have sys minus y0 plus 3. So Laplace of y is equals to ys. Please make sure you use the capital Y here. Okay, and also for this one, you need to follow what's given to you in the table of Laplace transform. Okay, so settle with the left hand side. So this one is equals to, so what is Laplace of sine t? So take, by looking at the table of Laplace transform, you will have 1 over s squared plus 1. You should by now be able to find the Laplace of this one. Okay, so the next step is you need to substitute the conditions given to you. Okay, so now you have an initial condition y0 is equals to 0. So now here you have y0 which is equals to 0. So you can cancel out this one. Okay, so you left with sys plus 3ys is equals to this expression. Okay, so the second step will remain as sys plus 3ys is equals to 1 over s squared plus 1. Why this one is cancelled out? Because of this one is equals to 0. Where did I get the 0? Is from the this one initial conditions given to you. Okay, so as you can see here, this is ys, this is ys, so you can factorize ys. Okay, so step number 3 is for you to solve your ys. So factorize ys will give you s plus 3 is equals to 1 over s squared plus 1. So therefore your ys is equals to 1 over s squared plus 1 s plus 3. Okay, so now from your t you have s, so you are applying Laplace transform. So now this is your ys. Okay, so what is next? Next, you need to apply inverse Laplace transform. Why? Because you need to find the inverse of this one. Because your problem is in terms of t. Okay, so your last answer must be in terms of t. So that's why you need to find the inverse of this one. Okay, so the inverse of ys is equals to inverse of 1 over s squared plus 1 s plus 3. Okay, so you know that the inverse of ys will give you yt. So what is your problem now is this part. Okay, so now check first, can you get this one directly from the table? The answer is no. Why? Because you have two terms for the denominator part here. Okay, so if you cannot find directly from the table, you need to come up with properties. So which properties is suitable for you to find the inverse of this function? Okay, so you need to identify either you want to use linearity or first shift or also rational function. So this is where you apply the knowledge that you had learned before. Okay, you need to identify on your own which properties is suitable for you to use. Okay, so as you can see here, you don't have to, you cannot apply linearity properties because you don't have anything to be split into two function, because you just have one for the numerator. So this one is not works. First shift, so do you have any s minus a term here? You might say this one, but as you can see here, you also have s squared plus 1 here. So s minus a is not works for this one. Remember when to use first shift. when you have s minus a to the power of n for denominator part, or you have in this form squared plus something or minus something, okay, or for the numerator you have s or s minus a or s plus a. Okay, so take a look back at my previous video if you don't understand this one. Okay, so first first shift is also not suitable in this situation, so the only left is rational function. Okay, so you need to find the partial fraction that is suitable for this function. Okay, so now you have 1 over s squared plus 1 s plus 3. Remember, I told you before, if you have a quadratic function, try to factorize if possible for you to get rid of using as plus b. But if you cannot factorize, then it's okay, just proceed. Okay, so as for this one, you cannot factorize it, right? So your partial fraction will be as plus b over s squared plus 1 plus, so this is a linear factor, so you will have c over s plus 3. Okay, so the next step is for you to find the value of a, b and c. So how are we going to find the value of a, b and c? So by comparing left hand side with your right hand side, so you will have 1 is equals to, so the first function is as plus b. So compare the denominator part. So you already have s squared plus 1. So the term that is missing is s plus 3. Okay, plus c. So for this one you need to multiply by s squared plus 1. So expand the whole expression here will give you as squared plus 3as plus bs plus 3b plus cs squared plus c, which is equals to 1. Okay, so the next step is factorize according to the variable. So the first one is s squared. So you will have a plus c s squared. Next one is variable s, which is 3a plus b s, and the last one is 3b plus c. Okay, so compare left hand side with the right hand side. So for the s squared, so this one a plus c is equals to 0 because you don't have s squared for your left hand side. So the second one is 3a plus b is also equals to 0 because you don't have s variable on your left hand side. So the last equation will be 3b plus c is equals to 1. Remember, when you have 3 unknown, then you need to have 3 equation. So solve by using calculator equation. Now your unknown is 3. So the first one is A, 1, B is equals to 0, C is equals to 1, D equals to 0. Equation 2, A is equals to 3, B is equals to 1, C equals to 0, D equals to 0. And the last one, A is equals to 0, B is equals to 3, C is equals to 1, and D is equals to 1. So therefore, your A is equals to negative 1 over 10. Your B is equals to 3 over 10. And your C is equals to 1 over 10. So, when you have all this value, you need to substitute back into this one. Okay? So, therefore, you will have the inverse of 1 over s squared plus 1 s plus 3 is equals to, so what is your A? So your A is equals to negative 1 over 10. So you will have negative 1 over 10 s plus, what is your b? Your b is equals to 3 over 10 over s squared plus 1. So the inverse of the whole function here. Okay, plus, so this one here, c, 1 over 10 is a constant, so you factorize. Why I didn't factorize negative 1 over 10 and 3 over 10? Because you have plus sign here. So just put whatever value you have first, then only you split into two functions. Okay, so 1 over 10 inverse of 1 over s plus 3. Okay, so now instead of finding the inverse of this one, now you just have to find the inverse of this function. So as you can see, for the second term here, you don't have any problem. You can get directly from the table. But this one, you have a problem because you cannot find the inverse of this function directly from the table. So what should you do is, yes, apply linearity properties. Okay, you need to apply linearity properties. Why? Because you have the plus sign here. Okay, so split the function into 2. So therefore the inverse of this one, so remember in the last, this one, the inverse of this one, which is inverse of, now you are solving on your right hand side. So on your left hand side here, inverse of ys will give you yt. So therefore yt is equals to, so use linearity properties. So negative 1 over 10 is a constant. So inverse of s over s squared plus 1 plus 3 over 10 is a constant. So factorize 3 over 10. So you left with 1 over s squared plus 1 plus the last function is 1 over 10 inverse of 1 over s plus 3. So as you can see, this one, and this one you can get directly from the table. So therefore, your yt is equals to negative 1 over 10 cos t plus 3 over 10 sin t plus 1 over 10 exponent negative 3t. That's it. Okay. So let's proceed with the second example, where you have y prime plus 2y is equals to 12 exponent 4t. Okay, so this is number 4. So how to solve this one? So first you need to apply, oh sorry, this is number 5. Okay, so first you need to apply Laplace transform. So you will have Laplace of y prime plus 2 Laplace of y is equals to 12 exponent, sorry, Laplace of 12 exponent 4t. So 12 is a constant, so you can factorize it. So you will have 12 Laplace of exponent 4t. Okay, so Laplace of y prime will give you sys minus y0 plus 2 Laplace of y is equals to ys is equals to 12. So Laplace of exponent for t will give you 1 over s minus 4. Okay, so now substitute condition. So this is the first step. So the second step is substitute the condition. So the conditions given to you is y0 is equals to 0. So that's Therefore, this one you can cancel out. So you left with SYS plus 2YS is equals to 12 over S minus 4. So factorize your YS will give you, so YS S plus 2 is equals to 12 over S minus 4. So therefore, your YS is equals to 12 over S minus 4 S plus 2. Okay. So now you need to find the inverse of this function. So clearly this one you need to apply rational function. Okay, because you cannot get directly from the table and you need to apply properties. Okay, so by using Laplace transform of rational function, so the inverse of YS is equals to the inverse of 12 over S minus 4 S plus 2. Okay, so now we solve for this part first. So solving for the right hand side first will give you, so 12 over S minus 4 S plus 2. So what is the partial fraction of this one? So this one is equals to A over S minus 4 plus B over S plus 2. Okay, so now find the value of A and B. So by comparing left hand side with your right hand side. So I'm going to do it fast because we already covered this one in the previous video. If you don't understand rational function or partial fraction, so please go back and watch my previous video. Okay. So expand the whole expression here will give you plus bs minus 4b. So factorize according to the variable. So a plus bs plus 2a minus 4b is equals to 12. So from two equations, so the first one will be a plus b is equals to 0, and the second one is 2a minus 4b is equals to 12. So by using your calculator here, so now your unknown is 2. So the first equation will be 1, 1 and 0, and the second one will be 2, negative 4 and 12. So therefore, your A is equals to 2 and your B is equals to negative 2. Okay, so substitute into this one and get the inverse. So therefore, yt is equals to, so A is a constant, so factorize. So 2 inverse of 1 over S minus 4 minus 2 inverse of 1 over S plus 2. So therefore this one you will have 2 exponent 4t minus 2 exponent negative 2t. That's it. Okay. So last example. So let's say you have this one. C y prime minus y is equals to t exponent 2t, and you are given y0 is equals to 1. I'm not going to solve this one till the end, but I will show to you how when you proceed in your own. Okay, so the first one is applying Laplace transform operator will give you Laplace of y prime minus Laplace of y is equals to Laplace of t exponent 2t. So please take a look at the function on your right hand side here. Before this, the first two examples that I showed to you just now, you can get directly from the table. But as for this one, there is no Laplace transform of t exponent 2t by using table. So you need to apply properties of Laplace transform here. So we already learned linearity, first shift, and also multiplying by Tn function. So you can either choose, either you want to use first shift or multiplying by Tn. Both can be used. Why? If you want to choose, remember when when you learn first shift properties, it must be multiplication of two functions, and one of the function must be an exponential function. And if you are going to use the third properties, which is multiplying by Tn function, remember the condition is one of the function must be t function. So you can either choose this one or this one. Okay. So the Laplace transform of y prime will give you sys minus y0 minus ys is equals to, so try to use either first shift or multiplying by Tn function, and you will have this answer 1 over s minus 2 squared. Okay, I'm not going to show how to get this one. If you don't know, then please go back to my previous video. Either for you can watch first shift, Laplace transform of first shift, or multiplying by Tn function. Okay. So the second step is applying condition. So now your conditions given to you is y0 is equals to 1. So this one you cannot cancel out. Okay. So simplify, this one will give you sys minus 1 minus ys is equals to 1 over s minus 2 squared. Okay. So before you can factorize your ys, this one need to be transformed to your right hand side. You need to remove this one to your right hand side. Okay, so you will have ys s minus 1 is equals to 1 over s minus 2 squared. This is minus 1, so when you on your right hand side it will be plus 1. So here you have a choice. Either you want to remain this function be two function, or you want to have one function by letting this one, so you need to do something so that the denominator be s minus 2 the whole thing squared. Okay, or you can just leave as this one. Okay, let's have a pro cons, so I will show you later. So therefore your ys is equals to 1 over, so the first function is s minus 1 s minus 2 squared, this one, plus 1 over s minus 1. If you proceed with this kind of problem, if you proceed with this one, please be careful, because sometimes student, when you solve for this part, you forget this one, because this one you cannot get directly from the table, and as you can see here, you need to apply partial fraction or rational function. Okay, so when you solve for this one, few students will forget to find the inverse of this one, so that is the problem. Or if you do something so that this one will become one function, you will have this one. Okay, so 1 plus, So this one 1, so you need to times by s minus 2 the whole thing squared over s minus 2 the whole thing squared. Okay, so this one will become 1 plus, so expand this one, s squared minus 2 minus 4s plus 4 over s minus 2 squared. So simplify this one will give you s squared minus 4s plus 5 over s minus 2 squared. So you end up with one function. So it's up to you. Either you want to let it be two function here, so you will have two function for your ys, or do something here so that it will become only one function. Okay, so therefore if you want to use this one, therefore your ys is equals to s squared minus 4s plus 5 over s minus 1 s minus 2 squared. So you can choose either you are going to use this one as your ys or this one as your ys. It's up to you. Okay, if you want to use this one, so please make sure when you're done with your rational function, you need to get the inverse of this one. Okay, and if you want to use these ys, please make sure you expand here and you don't make any mistake while expanding the expression here. Okay, so continue on your own until you get your, okay, if you use your ys is in this form or ys in this form, you cannot compare the value of a, b and c for partial fraction because you won't get the same answer. Okay, but don't worry, as we go, as you find your yt at the end, you will have the same answer. Okay, if your friend use this one as your ys and you use this one as your ys, your partial fraction might be different. Okay, so you cannot compare the value of the constant in the partial fraction with your friend. Okay, so if you solve this one, you will end up with the answer yt is equals to 2 exponent t minus exponent 2t plus t exponent 2t. Or you want me to show it? Okay, in my next video I will show you the calculation, because here you have t exponent to t, so you have to apply properties for you to get the yt. Okay, so see you in my next video and I will explain to you how to get this answer. Okay, thank you.